Now you're going to tell us a little bit about what you do and your research.
Okay, this is a wonderful platform for me, and I'm going to get a little bit excited, and so don't be scared away. My research is in experimental magnetic materials, and so I do experiments in order to study the properties of magnetic materials. Now, magnetic materials are very, very important technologically. I'll give you a couple of examples. Permanent magnets are extremely necessary in order for the functioning of electric motors, and these electric motors are a part of hybrid engines. Right? So that's one use. Also, permanent magnets are used in wind turbines. Right? I'll tell you a little bit more about these. The permanent magnets that are currently being used, the most powerful ones, are made of rare earth materials. I think you mentioned that in the introduction. And these rare earth materials, it turns out, are used in a wide variety of high-tech instruments, such as cell phones and TV monitors and so on. And it turns out that the supply is not enough to meet the demand right now. And so what people like me are engaged in is basic research in order to find other materials that can replace rare earth magnets because of the limitation in supply. So that's one aspect of my research. So in my laboratory, what we do is to study the magnetic properties of new materials, right? And we do that at very, very high magnetic fields, and we also do that at very, very low temperatures. So we are able to scan the properties of these materials from room temperature, let's say, down to 2 degrees above absolute zero, which is a temperature that you probably have never dreamed of, right? But we achieve routinely in my laboratory, and students have a lot of fun working with these materials and working at low temperatures. And so again, an important part of what I do is to study the fundamental properties of new materials and to look at the properties at a wide variety of temperatures, because often what happens is that there are properties, there are behaviors that occur at very, very low temperatures. Right? And unless you go to these low temperatures, you would never discover these kinds of properties. And it turns out that these properties may, in fact, be important for applications. One of these I might mention is superconductivity. You may have heard of that. And with a superconductor, you can conduct electricity, so current can flow through the superconductor without any heat dissipation. So one of the problems with electrical conductors right now is that when you conduct electricity, heat is dissipated, so the energy is wasted, right? So the power company that supplies power to you and I actually wastes energy, right? Because of the fact that the electricity has to be propagated across these wires, and a fair percentage of it is actually lost due to heat. And so with superconductors, none of that is lost. Right? And so the process of energy conversion would be much more efficient. So superconductivity was discovered at very low temperatures, right? And we haven't yet succeeded in getting a material to go superconducting at room temperature, where of course it would be most applicable. But that's one of the things that we're working on in research.